Good afternoon. I have to say first how pleased I am to be here and to be among so many familiar faces from past events, and also many new, to meet so many new people. This is a bit of now for something completely different, in that I think we're moving from discussion of how a well-established set of standards get deployed in the real world to the more chaotic situation of how a new technology is both simultaneously being deployed and there's standards work underway to try and establish the foundations for that. So I'm going to talk about AI and medical imaging, which is a topic that I'm sure is on the minds of many of the people here. And just kind of outline the activities that RSNA has been involved in to try and advance AI, and tie those back particularly to the work of IHE in defining standards to support the deployment of AI. I don't know how much level setting I need to do here, but there is a lot of hype around AI, particularly in medical imaging, and the reasons for it are kind of obvious, that imaging is important and expensive and widely deployed, and it requires great expertise, so there are limitations on its availability, and those are projected to get worse in that there is a growing shortage of radiologists worldwide, and AI has demonstrated capacities in this area. I mean, before the hype around large language models that came out of the advent of ChatGPT, computer vision was really the focus of this renewal of interest in AI. And AI also is capable of many other tasks that are useful within medical imaging. But just to continue with the context, there are articles published really every month about discussing the applicability of AI in radiology. And this is one just from earlier this year in the journal Radiology that showed that AI can do chest radiography screening with no loss of accuracy compared to human observers, which is an interesting finding. Not quite at the level of Jeffrey Hinton's pronouncement that we should stop training radiologists right now, if you remember from 5 years ago, but showing that there is no patient harm involved in using AI strictly for chest screening of chest radiographs. Another one, this one from around the same time, the European Urologic Open Science data, and this one for MRI for prostate, showing that while this one suggests actually that a partnership with an AI system and a radiologist is much better than either AI alone or a radiologist without AI. So at any rate, I don't know that I need to convince you that this is a topic of interest, but right now within medical imaging, disease detection and classification are kind of the primary focuses of AI. But there are other useful applications, as I said, and some of these we'll discuss in the context of demonstrations that we've helped organize. But doing image enhancement, protocol selection, workforce optimization, prioritizing work lists, and reporting assistance, including generating impressions as part of the reporting activity. So. And the FDA has approved over 500 devices, AI or machine learning enabled devices, and about 80% of those are in radiology. So again, I don't know how much I have to convince you that this is a topic of importance. But in order to implement the new technologies effectively, this is just my own personal kind of recitation of the methodology we've been talking about. I think the same as what Peter was saying in the previous presentation. You convene the group to define the use cases. You, in this case, get data to train and validate systems. You have to do on-site testing and compare the results to the results of human observers. You build products out of successful algorithms. And I think the key thing that we want to talk about here at IHE Experience Day is how you integrate those products into the clinical workflow. In doing that is really the IHE methodology. And that's coordinating the use of standards by getting together the stakeholders, again, agreeing to the use cases, selecting and documenting the standards, establishing and implementing testing processes. So I'm going to talk about 3 areas of RSNA's interest. The first is on conducting challenges, so kind of at the level of supporting AI research in AI. The second, which gets us more into kind of IHE terrain, is a set of demonstrations that we've organized at the RSNA annual meetings that show how AI is implemented in practice. And then the last one is back to actually talk about IHE-Radiology and the AI-focused profiles that have been created there. So since 2017, RSNA's organized now 10 AI challenges. So that if you're very clever, you'll count that there are 9 rows there, but 2021 we count twice because there are 2 challenges relating to brain tumor segmentation and radiogenomic classification. But so for each of these activities has produced large multi-site annotated data sets that are made available continually on a continuing basis or for research. They're annotated by specialist radiologists, often with data input from the contributing sites. The data themselves come from many different sites. The most recent one, the one that's going on right now, has a data set that's composed from 23 different sites, 14 countries, 5 continents. And each of these challenges has drawn hundreds of research teams from around the world to participate. This is just a screenshot of the current annotation activity. So this is actually the challenge that we're teeing up on lumbar spine degenerative disorders. And this is a platform called MDAI that's used for the annotation process. And it looks a little bit like a radiology reporting station, but it enables radiologists to apply labels in a very efficient manner and to annotate large bodies of data in a relatively efficient way. And we are entirely reliant on volunteer contributions of effort in this area. So it's good that it's efficient. And this is a screenshot of the currently running challenge on the Kaggle platform. And this just shows the leaderboard. I don't know if you can see, this one is approaching, we're about 10 days now out from the close of the competition. And there are, it says 927 teams. I think today we're over 950 teams. So there are amazing things. If you're interested in the topic area, I would strongly advise that you go and take a look at one of a challenge and look at the discussion board and see what, the extent to which this is. I mean, there's some prize money. It is a competition, but it's really a highly collaborative activity. And it's very common, for example, for competitors to build a model and then contribute it back to the community as a kind of baseline to just sort of level everyone up. So why am I talking about this? Well, it's been an interesting experience. I've learned a great deal about AI and the process of implementing it, but some lessons in particular that I think bear on our discussions here. The first one, which I think is obvious, data is precious. It's necessary. It's sort of the essence. if AI is going to be implemented, systems have to have access to good ground truth training and validation data. The second is that it's expensive. It's difficult to build these systems. I'm sorry, to build these data sets, and scaling that for detection algorithms across the very many things that radiologists do would be very expensive and is really kind of unsustainable in the current model. So the final kind of leap from that, logical leap, is that if we are going to do that, if AI is going to be implemented as a diagnostic tool across the areas of radiology, the feedback loops have to be integral. And that requires structured data, and that's sort of why we're here in IHE, is sort of to build that base of data and the learning health system, as it's called. Switching now to the deployment side, we have an activity that I'll talk about briefly, a series of demonstrations we've held at the RSNA annual meeting that I think are kind of like, they're very much built on the IHE model, but you might consider them kind of the first draft of IHE in the area of AI. They attempt to show how AI tools can be integrated in radiology, but also to demonstrate the interoperability standards that are necessary to achieve that. So we invite vendors, we have technical oversight to kind of organize them, and we build a demonstration around their capabilities and insisting that they use standards-based integration. This is just all the people who were involved in conducting that demonstration last year, and some of the faces may be familiar to you. These were the participating vendors. I would show you the ones for this year, but we have one more sort of qualifying event that they have to complete before they're ready to be officially part of the demo for 2023. And this is maybe the most important part of the work product of the demo, which is like the workflow diagrams you're familiar with from IHE, but kind of at a rougher level. Each of the numbered steps there is an area where AI is or can be involved. And for each of those, there's kind of a definition of how the AI tool gets access to the data it needs and how it provides its results back to the systems who are essentially listening for it. So there are underlying standards that enable the data that I'll just list here. And not say much more about them, except I'll come back to the IHE standards. Again, lessons learned. AI is going to be engaged at many steps along the value chain in radiology. Interoperability standards are necessary, and there's a lot of work to do. So I'm going to talk about some of that work that has gone on and is now going on, and I'll just touch on it briefly. And this is partly, I think most of the people in the room are probably aware of it, but this is largely sort of a call for engagement, I would say. So 2 profiles and a white paper have been developed in AI radiology since 2020. The AI workflow for imaging profile just specifies how tools are invoked and how the communications among systems are involved in the AI task. This has been tested only informally during the Atlanta Connect-a-thon last year. Fortunately, not any testing uptake at this event yet. The white paper outlines the whole landscape of AI and imaging and kind of try and define the problem space. And I'll just mention that it's a proposed work item for this year to reopen the white paper and drill down on details. So anyone who wants to get involved, please do. And finally, the AI results profile just describes the formatting of results produced by imaging AI tools, and then how those results are displayed and how the data is handled by receiving systems. And that, I'm happy to say, is being tested on the Connect-a-thon floor by 6 vendors this year. So we're very happy to see that as the first kind of end-to-end testing of the air profile. So I just want to give special shout out to the vendors who are involved in that. And really just my final call is just please do get involved in this work. We are at the early phases and it needs the expertise that I'm sure is present in this room. So with that, there are some links here that will be available with the slides. And that's it. Thanks.
Thank you, Chris. As we have the panel now, where Chris is participating, I propose to move questions to the panel.
It's not a question, it's just a statement.
Yes, sir.
So just a quick statement.
Probably a correction if I know Charles.
IHE-Europe has an AI group. In fact, what we're trying to do is to bring those vendors, and Mark is part of that group, and please join this effort. What we have found is that digesting this work is not easy for the vendor community. So that's what we are doing as a deployment committee, is to help mature, get ID, get feedback, and hopefully have a big uptake at the project-a-thon next year.
Yeah, great. Thank you.
Thank you, Charles. We can